Section 2.1, Set Concepts. A set is a collection of objects which are called elements or members of the set. Three methods are used to indicate a set: the descriptive method, the roster form, and the set builder notation. A well-defined set is one whose contents can be clearly determined. For example, the set of U.S. presidents is a well-defined set because its contents, the presidents, can be named. Write a description of the set containing the elements January, February, March, April, etc. So we recognize these are the months of the year, so we write the description of that. The set is the months of the year. Roster form, listing the elements of a set inside a pair of braces, is called roster form. For example, the set 1, 2, 3 is the notation for the set whose elements are 1, 2, and 3. Notice that these two options here on the left side there with the parentheses and then with the brackets do not indicate a set because it's not proper set notation. We have to use the braces. How do we name sets? Generally with capital letters. The definition of natural numbers is a set of natural numbers or counting numbers is n, and it begins with the number 1 and then goes 1, 2, 3, 4, 5, etc. Express the following in roster form. Set A is a set of natural numbers less than 6. Okay, so we know natural numbers begin at 1, and this says it goes up to less than 6, so it's going to be the set with the elements 1, 2, 3, 4, and 5. Set B is a set of natural numbers less than or equal to 45. Now, in this case, we don't necessarily want to write out all the elements, so we use the ellipsis there. We go 1, 2, 3, comma, and then the ellipsis right here, which tells us that the pattern continues in the same fashion until we get up to 45. P is a set of planets in the Earth's solar system, and the solution would be the set listed here that lists the elements, which are the planets in the Earth's solar system. The symbol there looks like an E, is read as an element of, and it's used to indicate membership in a set. If we put a slash through it, it means not an element of. Think of equal to and not equal to. It's a similar operation here. Set builder notation or set generator notation is a formal algebraic statement that describes the members of a set, and it's written between braces. And a variable may represent any one of the members of the set. So for example, write this set, the set B, which contains the elements 1, 2, 3, 4, 5 in set builder notation. So one way we can do it, here's how set builder notation is set up. We use the braces and we start with X and then a small vertical bar, X, which means such that X is an element of the natural numbers and X is less than 6. We can also write it like this and say that X is less than or equal to 5 because this would also give us a set B with the elements 1, 2, 3, 4, and 5. Write in words how you would describe set B in set builder notation, the set of all X such that X is a natural number and X is less than 6, or less than or equal to 5, depending on which notation you used. Write the set. Now we're going to give you set builder notation and go back to roster form. So the set A is X such that X is a natural number and X is between 2 and 8 inclusive. So here's the set, 2, 3, 4, 5, 6, 7, and it includes the endpoints. It doesn't include 8. I'm sorry, it's not inclusive of 8. It's less than 8, so it stops at 7. A finite set, a set that contains no elements or the number of elements in the set is a natural number, is called a finite set. For example, the set B, which contains the elements 2, 4, 6, 8, and 10, is a finite set because the number of elements in it is 5, and 5 is a natural number. An infinite set is a set that's not finite. The set of counting numbers is an example of an infinite set. This set here, 11, 12, 13, and notice the ellipsis, it's going to keep going and going. This is an infinite set. Sets are equal if and only if set A and set B contain exactly the same elements. For example, these two sets are equal. The elements do not have to be in the same order, but they have to be the exact identical elements. The cardinal number of a set, which is symbolized with this nomenclature right here, n, paren, capital, and then the name of the set, is the number of elements in set A. For example, if we have A, which is equal to, contains the elements 1, 2, and 3, and B, which contains the elements England, Brazil, and Japan, both have the cardinal number of 3. Equivalent sets have the same cardinal number. This is different from equal sets, which have the same elements. For example, these two sets D and E have the same cardinal number, but they're not equal, but they are equivalent. They both have 3 elements, so therefore they're equivalent. All sets that are equal must also be equivalent, but the converse is not true. Not all equivalent sets are equal. So for instance, these two sets we said were equivalent, but they're not equal because they do not have the same elements, even though they have the same number of elements. One-to-one correspondence, two sets can be placed in one-to-one correspondence if every element of set A can be matched with exactly one element of set B, and every element of set B can be matched with exactly one element of set A. So therefore, they basically each have to have the same cardinal number. So consider set S, which is states, and C, which is state capitals. We can put these into different one-to-one correspondences. For instance, here's one here, where we just go ahead and put them in order and do a one-to-one correspondence. But this one doesn't make a lot of sense. A better one might be to do it this way. And why is that? Because what we're doing is matching the state to its capital. Other one-to-one correspondences between those two sets are also possible. The null or the empty set is a set that contains no elements, and we can use two different symbols. We can use the braces with nothing in between them, or a special symbol there which looks like an O with a line through it, which is the null set symbol. Notice that this set here is not an empty set. This is the set that contains the element, the symbol for null set, and it has a cardinality of one element in it. The same thing with this set here. This set contains one element, 0, and it has a cardinal number of 1. The universal set, symbolized by capital U, is a set that contains all the elements for any specific discussion. When the universal set is given, only the elements in the universal set may be considered when working with the problem. And we'll see this as we move into the next sections. So for example, if the universal set was defined as 1, 2, 3, 4 through 10, then only those natural numbers 1 through 10 can be used in that problem. Determine if the statement is true or false. If it's false, give a reason. So here we have, on the left side, we have a set with a single element C, and then we see a symbol for element of, and then we see a set on the left with 4 elements A, B, F, and G. So notice again, that symbol there means element of, but we see that we have a set on the left side. So this is a false statement because a set is not an element. A set is a set, and in the next section we'll see symbols for subsets and things like that, but this is a false statement. Let's look at this one. We see D, it says, is not an element of the set on the right. This is true. D is an element, but it is not a member of this set.